Hey everyone, this is FrSky Steve. Welcome to the channel. Today we're going to be talking about working with telemetry and Ethos. I'm going to break this up into 4 sections. This is a hands-on guide. Mostly we're going to be watching this from a simulator. So the 4 sections are this. First, we're going to start off creating a new model, registering, binding, and turning on telemetry. We're not going to spend a lot of time on this because there's a lot of videos out there that talk about registering and binding. We just wanted to get people through the process. The next section, in section 2, we're going to talk about setting up FBUS in the receiver and changing telemetry options. In the third section, we're going to create a logic switch for stall speed, and we're going to turn on shaker sticks if available. In the last section, we'll set up a display on the monitor of your transmitter to show telemetry as you're flying. With that, let's get right to it. First section, we're going to create a new model, register, bind, and turn on telemetry. Okay, so now we are going to start working with the Ethos simulator. This is a screen of what would look like if you were working on the transmitter. So what we're going to do is we're going to create a new model, and we go into model select. The same thing as pushing this is the airplane icon or the model file. Go to model select, and I hit plus, and then go to create model. We're going to create an airplane. It's a non-stabilized receiver, and 1 channel for the propeller. There's only 1 motor, 2 ailerons. We're going to say this has flaps, traditional tail, and maybe, well, we're going to keep it simple, just like this. We can give it a name, call it test plane. Such a creative name, I know. And I don't have many photos on here, so what we've done is we've gone ahead and we've set up a model. So we created a model, and what we might do is we're going to look at mixes, and you can see we don't have a source, which means we don't have a way to turn the flaps on and off. Go into here to edit, input, I'll put it on switch A. I would just flip switch A, and now we have a completed model. So what we're going to do now is we're going to register and bind the receiver, since we already have a model set up. So we're going to go to the RF section, and this is your owner registration ID. If it's the first model you've set up, you can change this. You can use your nickname or something like that. And we are going to turn on the internal module, because that means we use the antennas. If we use an external module, it assumes that you have something else plugged in the back of the transmitter. We're going to take the state from off to on, and we're going to switch this to the TD mode. It's channels 1 through 16. And the antennas are internal. Power, I might do 25 milliwatts. It's a little more power. You don't need to turn it all the way up. It's not going to get you more range per se. So registration and binding. All we have to do is, it's like there's a button on the transmitter. Sometimes they're a bit hidden, but they're there. And what you do is you push it in, and you hold it in as you hit the registration button. And what happens is, after a couple seconds, you'll see this pop up. You'll see that there's the name of the receiver or the type. So if you had a TDR10, for example, it would say TDR10, and then it will also confirm this is your passphrase right here, which is your registration ID. And all you do is hit register, and one more time to say OK. And now we're going to go to bind. So we're going to go to the RX section. It's saying bind, waiting for receiver. All you do is plug in the receiver, and it will pop up. There would be like a TDS or a TDR10 option, or one of the other ones, but this is a simulator. Okay, so now what we're going to do to finish this off, since we've registered and we've bound, in a previous video I mentioned that you want to see these powered up right here, showing that you're receiving. If you don't see this, that means you have to update your receivers. If those come out blank, if there's zeros there. Alright, so what we're going to do is get out of here by hitting return, and we'll scroll over to the next page here to go to telemetry, and we're going to turn it on, and we're going to wait a few seconds. And a whole bunch of telemetries just came on. Okay, so now we're going to start talking about setting up FBUS in the receiver and changing telemetry options. And before we get into this, you might want to wonder, what is FBUS? And so there's terms you might have heard of before, like SBUS, which is a serial bus communication. It means essentially it's a bunch of zeros and ones being transferred in high rates of speed from the transmitter to the receiver. And then there is smart port, which is telemetry back from the receiver to the transmitter. So the issue becomes that when you're dealing something like with, for example, this exact servo, which we covered in another video, this has telemetry built into it. So from the receiver, you want to send information to the servo. So you have power and ground, so it can power the servo. And then there's another wire that's the signal that goes from the receiver to the servo. And what it's saying is that it puts out the signal wire for that to tell the servo when to turn, when to go back to center, everything else like that, right? However, if you want to get telemetry back, you can't do that in 3 wires because smart port needs another wire. So we would have these really funky 4-port connectors on our receivers, and it would be a big mess. And what we figured out how to do was combine smart port and SBUS together. The way we did this is by making the signal wire bidirectional. So the signal that comes from SBUS goes one direction, and information coming back from telemetry from smart port goes the other direction. And that's FBUS. It's a combination of SBUS and smart port. Okay, now we're going to turn on FBUS, and we're going to talk about how to manipulate things inside of Ethos as far as working inside of the telemetry options. So start off with, let's get in here and we're going to turn on FBUS. So to do that, we go into the airplane icon, go to the RF section, go to the bottom down here. We're going to go to where we have this receiver. You click on it one time, go into options, and the simulator is kind of flaky when it comes to this. Sometimes it works, sometimes we have to give it a couple tries. So the first time didn't work, we'll try it again. Usually by the 3rd time. Oh, we got it the 2nd time. This is great. So as you can see right now, I have things like reduce power to 25 milliwatts. If you don't have shaky servos, you can turn this off. You want to have as much telemetry power as possible on 900 megahertz. We're going to make sure telemetry is turned on. And this is for high-speed servos. We're using FBUS as far as a telemetry port. And people ask, how do I get 24 channels to work? What if I wanted to use channels 17 and 18 on my receiver? Or if you're using an RB unit where you want to get all 24 channels working, you change it right here to SBUS 24, and then all 24 channels work. But by default, there's 16. Anyway, we always think about things as far as pins are concerned. So pin 10 means it's channel 10, and that's traditionally how we think of things. But the truth of the matter is pin 10 can be channel 11 if you want. Try it again. So you can have channel 11 come out on that. You can have channel 11 come out on pin 11 as well. So, but the reason I point this out is because what we're going to do is we're going to go down to 24. After this, on a receiver, it doesn't show it in the simulator, so you have to just imagine what I'm telling you here. The next one's going to say something like SBUS out, and it's going to say smart port, and then it's going to say FBUS. You want it to say FBUS, so by the time that you're done, this will say pin 10, it's on FBUS. So we plug our telemetry items into that FBUS port. Okay, now we're going to go into the next section here, which is telemetry, and we're going to talk about how we get some of those telemetry items working. And I was talking about an airspeed sensor. So that's always a fun one. We're looking for airspeed. We go down here, and you can see we're doing 92 miles an hour right now. You go into edit, and we have a number of things we can do inside of here. We can change it from miles per hour to feet per minute, for feet per second, kilometers an hour, knots, everything. One thing that drives me crazy about this, and the reason I brought this up, is that sometimes these decimals are set to 2 points. So you can be flying 575.38 miles per hour. And when it's calling out airspeed, those points drive you insane. So the first thing you should do is change this to 0. You just want whole round speeds. And the right logs is on. So I am going to talk about, I've also mentioned before things like GPS. This gives you an opportunity to see where you're at in the course. Every time it records on a telemetry log, it's going to tell you exactly where you were. So if you're recording 1 time a second, you'll get 1 telemetry log file per second. If you're recording, they're measured in milliseconds. If you're doing 50 milliseconds, that means 20 times a second. You'll get it. I usually like 250 milliseconds, which is a quarter, and that's 4 times a quarter of a second, or 4 times a second. You get a telemetry log. We get clock, actual time. We get the actual GPS speed, and you can get also altitude and the course direction. That's why I always find the GPS module to be pretty worthwhile. All right, now the question is, we need to be able to record this so we can go back later and look at this. How do you do that? So before I take you into this, tell you this secret, I want to show you one thing. In the mixes, I went in here and I set up something called a throttle cut. So I put it on switch H down. Actually, I want to have it on switch H up. I changed my mind. Here we go. And you can see that as soon as I do that, that red dot right there means that we're recording telemetry. All right. Now, how did I start recording telemetry? I went into this next section here, and under special functions, I set up a write logs. So first thing you did is scroll down till you find write logs, and I turned the state on to enable. And I'm going to get rid of this for one quick second, because what I did was I went in here and I set up a system event, which is throttle cut. And what that means, you can see the light went off, right? What this means is that whenever the throttle cut's on, it will start writing telemetry. So that means you get no telemetry while you're flying your plane, but as soon as you land and turn off your throttle, it starts to write telemetry, which is completely useless. So what we want to do is we go in here, and you have to do a long press on it and select invert. And what that does is it sets up a not switch, which is an exclamation point. So what this means is that it will start writing whenever throttle cut is not on. And you can see this light right here go off. And when I press switch H, it comes off when throttle cut is on, and as soon as throttle cut is off, it starts writing telemetry. So very useful stuff right there. Okay, now we're going to set up an airspeed sensor to tell us when we're about to stall. This is very important, especially for landings. So what we'll do, first of all, let's talk about stalling. The idea is that you get to a point where the plane is so slow that it can no longer maintain flight. What it will do, sometimes if you're up high enough, it will drop the nose down and pick up altitude. Sometimes it will roll over. It really depends on the plane. You don't want to get below stall speed, especially on landing when you're at a very windy place. Being able to maintain airspeed is crucial to completing a mission. So let's get in here right now, and we're going to go to the airplane icon right there, which is the same as hitting model. Go over to the next page right here, set up logic switch, hit plus. We're going to name this airspeed. And we want to use A is less than X. What is A? We're going to use telemetry. And inside of here, we're going to look for the airspeed. Oh, there it was right there. I found it. All right, hit return. 0 miles per hour. Let's say our stall speed we determined is 35 miles per hour. How do we figure out our stall speed? What we do is keep flying a plane with the airspeed sensor on. It will tell us your speed. Maybe it says 40 miles an hour. You slow it down a little bit. 39 miles per hour. A little bit more. 38 miles per hour. Things are still fine. When you get to 35 miles per hour, you see that it drops the nose, the wing rolls over, something like that. It means that's your stall speed, and that's what you want to try to avoid. So we determine it's 35 miles per hour on this plane, and we're good. And with that, I would say, I want to show you one other thing. Since I don't have an actual working airspeed on here, if it dropped below 35 miles an hour. So if I was going faster than 35 miles per hour, this would be red. But once I get below 35 miles per hour, this turns green. And let's see. When that happens, that means that condition is true, and we can apply that logic switch. So we go into special functions, and all I do is go in here, and I want to, first one I want to set up is play audio. So I'm going to enable it. And when I go in here, I'm going to use a logic switch. Since we only have one logic switch set up, that's all you need to do. And I am going to add a new sequence and line here, and I'm going to play a file. The problem I have is I did not set up something that says stall, and that really should be something you set up. So I'm going to go down here, QRS, telemetry. It's going to call it telemetry. Let you know it's stall speed. All right. And at some point you can create your own sound file that says stall. So the idea would be that once this logic switch comes on, it will repeat once. Maybe that's not enough. Maybe every 2 seconds you want to know that you hear telemetry, or stall. The idea would be that it lets you know you're below stall speed, and let's speed the plane up a bit. Now that I've done that, I'm going to create another logic switch. This one is going to be a haptic. It's going to be enabled, and the condition again is going to be the logic switch. So go to logic switches right there. There's only one, and I'm going to get a pattern of 3, and the strength is going to be, I'm going to set it pretty high. I'm going to set it about 8. So it's going to give 3 jolts every single time you're below airspeed. Plus, it's going to do an audio call out. If I had, there's something missing right here. If I had the X20 RS, what would happen is I'd have an option to have haptic play, shake the whole transmitter, right stick or left stick, and I would want it to be the left stick. So, and that would do it. So essentially we have now set up a logical condition, and we've also set up an audio call out and a haptic feedback call out on our transmitter, so we know that whenever we're at stall speed, a lot of things are going to start happening, and it won't go away until you speed your plane up a little bit faster as you're landing or whenever you're flying around. Cool stuff. Okay, it's time for Kung Fu Geekdom. This is where it all comes together and all pays off. We are going to have ourselves a new screen. I've actually built it, but I'm going to build it again for you. This is what it looks like. So what we have is a 5-minute countdown timer. It's started by whenever you throttle up. you can keep track of airspeed. So the idea would be someone would stand next to the pilot and start letting him know what's going on. So let him know how the airspeed is, let them know how much LiPo battery they have left, the total amount of juice left in the battery, and also let them know how much current they're drawing as they're flying. Okay, so really cool. How is this done? Well, the first thing is, let's look at this timer. We can click inside of here and work on it. I kind of find it's better to look at it as far as looking at from here, because you can see that there's the mode is, it's a countdown timer. Start value is 5 minutes. There's no alarm, but the start condition is throttle active, and the ending condition, or for resetting it, is throttle cut. So how did I set it up? Go inside, give it a name right there. Mode was down. This is where I put 5 minutes in. Throttle active is a system event, throttle active. So that means that it's when the throttle is not in, it's off of a throttle cut and it goes up, it will start counting down the timer. And the reset is throttle cut. So that, again, that's a system event, throttle cut. And what I did is I put a couple things in here. At 2 minutes, at every 15 seconds, it's going to count out the time. So we'll say 2 minutes, we'll say 1 minute 45, 1:30, you get the point. Then at 10 seconds, it will start to beep. So you should be landing right before or around there if it's a 5-minute race. Okay, we got that set up. Now, the rest of this, it's pretty straightforward how I set it up. So I'm going to make a new one. So I'm going to go in here, hit this, that is your screen. We're going to give a plus right there, and we'll choose that one. This is the 4-screen layout. First one I did was a value. I configured the value. This one is going to be a timer. The timer I used the 5-minute down. That's why you want to name it. That is up on the screen right there. Second one is also a value. This one is going to be telemetry. Which telemetry did I use? I believe this one I used airspeed. There. Third one, I go in here, value. Which value did I use? It's going to be also telemetry. And this one is going to be, this is the second LiPo. It's just the way that this is set up, so it displays there. And the last one, as you can guess, also value, also set up for telemetry. Pretty much repetitive stuff here, right? Not taking very long to set it up. This one I'm looking for is current. I thought it was up here. There it is right there. Almost had it. Here we go. And with that, I have, they're both identical. And as soon as I turn throttle cut off, you'll see that at the very top right here, you'll see that little red icon means it's recording. And with that, I'm able to go into here, and as soon as I put my throttle up, it has to be above 5%, the countdown timer comes on, and we're flying. And then the person who stands next to you will keep track on the screen to see what's going on. If there's ever an opportunity to think about getting an X20R or X20 RS over the X18, this is it, because you can have a person standing next to you, and with a larger screen, it's easier for them to keep track of what's going on and don't have to be on top of the pilot. All in all, this is great. I do thank you for watching. I do thank you for following along. Please let me know if you have any questions. Thanks so much.